Okay, let's jump right in. We're doing a deep dive today into a fundamental problem that every sound engineer at a big venue has to face.
Right. The physics problem.
Exactly. How do you send, I don't know, dozens of critical audio channels over these massive distances without the signal just turning into a mess of noise?
And that's where we're looking today. We're unpacking the Thor broadcast F-32A-RCA-TxRx.
It's a system designed to handle 32 channels of line-level audio,
Okay.
but it does it by completely throwing out the copper rulebook and turning audio into light.
Well, what's so fascinating here is that this technology, it isn't just a small upgrade. It's a total paradigm shift.
How so?
Because signal degradation, radio frequency interference, these are the things that haunt any long copper cable run. They're physical limitations.
Sure.
This system just bypasses that entire struggle. Our mission today is to really get how this perfect digital stream of light just solves all those issues.
So the core promise here is really about simple, robust signal delivery. You're taking your standard line-level audio, maybe from a mixing board, and just sending it easily with no loss in quality.
And this kit handles 32 channels, which, is a huge chunk of any big professional setup.
Right, and the kit has everything, the transmitter, the receiver, power supplies. You're ready to roll.
And the switch to fiber is what gives you absolute purity. The audio is converted into 24-bit digitally encoded broadcast quality audio.
Which is already very high quality.
It is, but because it's a completely digital platform traveling on glass, you get that critical benefit: total immunity to electromagnetic noise.
The spec sheet even says, no interference from adjacent power lines, sources, or other.
And that's everything. Copper picks up all that ambient static. Fiber just makes noise totally irrelevant for the whole run.
And you can see that purity in the specs.
Yeah.
We're talking about a super flat frequency response. It goes from a deep 10 hertz all the way up to 29 kilohertz.
All within plus or minus 3 dB. It means you're hearing absolutely everything. And look at the SNR, the signal-to-noise ratio. It's greater than 70 dB. For anyone out there tracking fidelity, that number tells you the audio is basically pristine.
And that's even before we get to the distances it can travel.
Oh, yeah. The distance is the other half of the story.
So purity is one thing, but it's useless if it can't get to where it needs to go. Let's talk range, because this is where it gets really interesting for staging.
Okay.
The kits can use either single mode or multi-mode fiber. With multi-mode, you can run these 32 channels up to 2 kilometers.
2 kilometers, that's already enough to cover a massive festival site or a theme park.
A huge distance.
Yeah.
But then you switch to single mode fiber.
And that's where it gets wild. You can transmit those 32 perfect channels up to 20 kilometers.
20 kilometers. That's for, like, broadcast trucks parked miles away from a stadium or running clean audio across an entire university campus.
Exactly.
And since this is for mission-critical stuff, reliability has to be everything. The source material talks about it being plug and play.
No configuration needed. You just plug it in.
But what about the physical side? They quote an MTBF of over 100,000 hours. What does that mean? Time between failures number actually signify for you in a live production?
It means you can trust it. 100,000 hours. That's over 11 years of continuous nonstop operation.
11 years.
So for a rental company or a major venue, it completely validates the investment. When you're running a huge concert, failure is just not an option. You need that robustness.
And it uses the professional STPC optical connectors, so it's built for real-world work.
Right. Heavy, dusty, real-world work.
Which makes sense when you see where it's used: staging, concerts, theaters, stadiums, theme parks, broadcast studios. You can picture it, right? Running clean audio from the main stage at a festival back to the broadcast tower 2 miles away. This technology makes it happen perfectly.
So the core technical achievement is taking 32 analog audio channels, converting them, and just sending them 20 kilometers.
Digitally, perfectly, and completely free of all the interference that just cripples copper.
Which leaves you with a really interesting thought to mull over.
Go on.
If professional AV tech can effortlessly maintain 24-bit broadcast quality audio over 20 kilometers and do it in an extreme temperature range from minus 20 to plus 75 Celsius,
Yeah.
well, what does that tell us about the capabilities and the limitations of high-fidelity audio transmission in our own everyday local setups? It really suggests that the technological ceiling is just so much higher than most consumer gear ever lets us realize.